Hello again, and today we're going to do the first question of section 2 on the Archimedean property. So the Archimedean property, hope you've understood it, but it basically says there's always an integer n, or natural number n, greater than any real number. Okay, so question 1 is proving that if x is a real number, then there's a positive integer n such that x is between negative n and n. Okay, I'm looking at this and immediately I see the absolute value of x is less than n, because on the number line, and we've done this for the section 1 questions as well, but if x is here on the number line and you've got an n and a negative n, hold up, I'm gonna change that to 0. Okay, if that's 0 and you've got n and negative n, and you choose some x in this region here, between 0 and n, negative x, if you take the absolute value of it, is also going to be in this region. So negative x is going to be in this region. So you can, this is negative x, this is x, absolute value of negative x equals x, right? So all you have to do is say the absolute value of x is less than n, because that includes negative x is greater than negative n. Okay, so once we've done that, I don't know if you can see this, but I see the Archimedean principle already. And if you look at what we went through, what I wrote down for the intro to the Archimedean property on the Rakugaki, it says that what the math sorcerer did is he found a case where he was finding an integer that was greater than a real number. And we've done that right here. We have an integer greater than a real number. Okay, so now we can say, since the absolute value of x is a real number, by the Archimedean principle, I'm going to write that as AP, like the math sorcerer does, there exists an n, a natural number n, an n in the natural numbers, such that, that's 2 dots for such that, n is greater than the absolute value of x. This implies that x is greater than negative n, which is less than n, which is just rewriting this over here without the absolute value sign. And that should be the end of the proof. That was really easy, and I'm gonna go check at what the math sorcerer did and possibly write some comments on the Rakugaki. Okay, I'll see you in the next one.